Number 1, we're supposed to simplify. Since the log has the same base as the argument, then this whole thing just becomes 6. It's one of the identities for logarithms. Number 2 is very similar. Since the base is a 56 and it's raised to an exponent, and that exponent has the same base as the logarithm has the same base, the 56's are the same. This is the other log identity, in which this whole thing then just becomes the argument, which is x. Number 2 is the same, number 3, which is the same principle as number 2. We would like to be able to say this answer is just 2, because we have a base of 5, and our logarithm, which is an exponent, has the same base. But we can't just call the answer 2, because we have this 3 hanging out in front of the logarithm. So what we have to do is we have to use the product, or the power property, take the coefficient of logarithm and make it the exponent for the argument, which would make this 5 to the exponent of log base 5 of 2 cubed. 2 cubed here is 8. So that's going to make this equal to 5 to the exponent of log base 5 of 8. Now, since the base is a 5 and the exponent is log base 5, this whole thing just becomes the argument of the exponent, which is 8. Number 4 is just like number 1. We have common log of 10 to the 9th, which is going to equal 9. Common log means that the base is 10, but it's not written. Number 5 is just like number 4, which is just like number 1. We have natural log of e to the negative 2, which is going to be the exponent of negative 2. Natural log means it's log base e. This problem could have been written as log base e of e to the negative 2. So 1, 4, and 5 are identical. So far, 2, 3 are closely related. You'll find here that 3 and 6 are basically identical. Same concept here, 6 as it was for 3. We have a base of e that has an exponent, which is natural log of 8. Natural log meaning its base is e. To simplify this, we need to get this coefficient to be an exponent. So this is equal to e to the e to the natural log of 8 squared. 8 squared is 16. 8 squared is 64, I should say. Let me rewrite this. I'm in such a hurry that I am taking more time. Now, since this base is e, and the exponent's logarithm has the same base of e, this whole thing becomes the argument of the exponent, which is 64. Number 7, natural log of e is 1, and the reason is natural log means log base e of e. So this is saying e to what exponent equals e? Well, it would be e to the first equals e. So that's why this is 1. You don't need to show that work. Number 8 is the same as number 6, which is the same as 3, which is the same as 2. Our base is e. Our exponent for that is a logarithm with a base of e, so the whole thing becomes the argument of the exponent, which is 5. Number 9 is very similar to some of the other problems here. We have natural log of e to the 5th. One of the identities tells us that this is 5. That's because the natural log means log base e. The argument is the same base, so this whole thing just becomes the exponent. You don't need to show this work. Number 10 is the same as number 9. We have log base a. Our argument is a to the 10th, so the whole thing just becomes the 10. Number 11, log base 8 of 8 to the first. The first isn't there, but it's implied, so that equals 1. Number 12, we can't just say this is 2. This is not 2 because there is a negative in front of this logarithm. That negative in front is like saying negative 1. I'm just going to exaggerate this a bit. So it's 10 to the negative 1 times common log of 2. We can take this coefficient and write it as an exponent for the 2. 2 to the negative 1 is 1/2. So this is 10 to the log of 1/2. And now since the 10 has an exponent, which is log base 10, this whole thing becomes the argument, which is 1/2. The rest of these problems are solving equations, and in most cases, if it's possible, you want the base of your logarithm to be the same as the base of your argument. So for this problem, this common log, it means log base 10, we want that base to be the same as this argument. 0.01 is the same as 1/100th. So the question is, how can we write 1/100th as a base of 10? Well, 10 to the first is 10. 10 to the second is 100. We need this to be 100th. So that means 10 to the negative 2. 10 to the negative 2 is 1 over 100. 10 over negative 2 is the same as 1 over 10 squared. 10 squared is 100. So then this left side just becomes negative 2 because the base of log is 10 and the argument is the same base. So the answer just becomes the exponent. Number 14 is the property of equality. The left side of the equation is a single log with an argument. The right side is a single log with an argument. Since both of those logs have the same base, which is 10 because it's not written, you can make the arguments equal to each other. Solving this equation, divide both sides by 3 and you get x is 12. Number 15, on the left we have natural log of e squared. This left side simplifies to just 2 because natural log means log base e, and then that's arguments e squared. So that whole thing just becomes 2. We've shown that many times on the first several problems. The left side is x plus 6. If you subtract 6 from both sides, you get x is negative 4. Number 16. This is the product property. If you're adding two logarithms with the same base, natural log of 5 plus natural log of 6, you can write that as natural log one time and multiply the arguments. 5 times 6 is 30. Using the property of equality again, since the left side is natural log and the right side is natural log, you just set the arguments equal to each other, so 30 equals x. Number 17 is the quotient property. We got two logs with the same base that we're subtracting. You can write that as 1 log, base 10, or common log, and then take the first argument divided by the second. Using the property of equality again, since both sides is common log of an argument, you can set the arguments equal to each other. Therefore, x is 12. Number 18, I'm going to do this one a couple times for you because I've done it one way every time, and it doesn't seem to be helping some of you, so you're going to see something different here. This is the product property again, log of an argument plus log of an argument. You can make it a log of the product of those arguments. X minus 2 times x plus 2 is going to end up giving you x squared plus 2x minus 2x, those middle two terms cancel, minus 4. So as I've showed you this many times before, maybe write down what the base is for the logarithm. If nothing's there, it's implied it's at 10. If you change this to exponential form, you get 10 squared equals x squared minus 4. 10 squared is 100. If you add 4 to both sides, you get x squared is 104. And if you square root both sides, you get the square root of 104 equals x. It's plus or minus technically, but if you put a negative 104 into this, your argument's negative, and the argument can't be negative. 104 simplifies. If you make a factor shrub, you can break this into 4 and 21, I think. That's not right. 4 and 26. 4 is a perfect square, so this is 2 times the square root of 26 is what x is. Let me show you this problem in a different way. Once again, here's a different way to do number 18. So we started out the same way. We got the product property. You're adding two logs with the same base, so you multiply the arguments. Then, since we know the property of equality, which says if you have a log on one side of some argument equals the same log of an argument, you can just make the arguments equal to each other. So what you could do here is think, how can I make 2 into a logarithm? Well, that's actually pretty simple. Just using one of these identities that we used before, kind of backwards. If we make both sides log base 10, because this one on the left is base 10, of an argument that's 10 to the 2, hopefully you'll agree that that's the same thing here as 2. Because this whole thing is going to cancel and you're left with 2, which is the same as what that was. Once again, if this method works for you, do it. Then, since the left side is log base 10 and the right side is log base 10, then we can make this arguments equal to each other. X squared minus 4 equals 10 squared. And then at this point, it's just like the way we did it the first time. Number 19, what we would like is we would like this log base 10 to have the same base as this argument. So we could rewrite this as negative 2 times common log of 1/10. 1/10 you can write as 10 to the negative 1. And then we can take this negative 2 and write it as an exponent for our argument. So it's common log of 10 to the negative 1 to the negative 2. Using the power of a power property for exponents, that would be 10 squared. So since this is common log of 10, this whole thing just becomes 2 equals x. Number 20 is similar. You can take the 4, write it as an exponent for the x, so it's a common log of x to the 4th. Using the property of equality, since both sides are common log, you can set the arguments equal to each other. Take the 4th root of both sides, and you're going to get x is plus or minus 3, but it can't be negative 3 because your argument we defined earlier as having to be always positive. Number 21, I will do this in 2 different ways, like I did number 18. There's lots of ways to do this. I'm going to show you 2. You could, since we have a coefficient here for the natural log, and the right side doesn't have any logs, you can do this anyway, but you might want to choose to do this. You can divide both sides by 3. That would give you natural log of the argument x minus e equals 1. You then could change this to exponential form. This natural log has a base of e. So it's e to the first equals x minus e. Getting x by itself, add e to both sides, and you get x is 2e. Let's do this problem again. Another way to do this problem, take the e and write it as an exponent for the argument. And then the right side How can we change 3 so it's a natural logarithm? Easy. Make it natural log of e cubed, because natural log of e cubed is equivalent to 3. Then, since both sides are natural log, you can make this x minus e cubed equals e cubed. Cube root both sides, add e to both sides, and you get x is 2e. A little bit different method than the first time I did 21, but the same result. 22, we want to add these two logarithms together by multiplying their arguments, but we currently can't do that because they have these coefficients. So to make them not coefficients, you make those exponents for the arguments. Two to the negative 3, that's the same as 1 over 2 cubed, which means 1/8. So this is natural log of x squared plus natural log of 1/8 equals natural log of 8. Product property, you're adding two logarithms with the same base, so you can multiply the arguments. Now we can write the arguments equal to each other. Continuing to solve this, I'm running out of space, so I'm going to borrow some space over here. If you multiply both sides by 8, you end up with x squared is 64, and then square root both sides, you get x is plus or minus 8, but this is an argument, and the argument has to be positive, so x is just 8. Number 23, we would like to multiply these arguments on the left since we're adding the same base, but we can't currently because of this negative in front. That negative is like it's a negative 1, so that would be log of x to the negative 1 plus log of 20 equals log of 5. You could then multiply your arguments on the left, so you get common log of x to the negative 1, which is the same as 1 over x, times 20, that's the argument, equals log base 5. Since both sides have the same log with the same base, you can set the arguments equal to each other. If you multiply both sides by x and divide both sides by 5, you get x is 4. Number 24, we could write the 2 as an exponent for this. So that would be log of the argument x minus 2 squared. From here, we can take two different paths. I'll do this two different ways. One way, we could change this to exponential form. 10 squared equals x minus 2 squared. Square root both sides. Technically, that's a plus or minus 10, but if you continued to solve this, you would end up with a negative 8 for x, and if it's negative 8, it makes the argument negative, and the argument has to be positive. So it's going to be positive 10, which makes x 12. Different method to do here is to change the right side of the equation. So I don't have enough space. Let me write this someplace else here. Let me steal from 23. Another way to do this would be to make the right side of the equation, the 2, a logarithm. You can do that by writing it common log of 10 to the 2. Now, since the left and right sides are both common logs of an argument, you can set the arguments equal to each other. It's almost identical to what we did here, but conceptually it's different. Square root both sides, and you get x is 12. Technically, once again, this is plus or minus 10, but if it's negative 10 and you add 2 to it, it's negative 8, and the argument can't be negative.